Okay, so I was explaining the square root of 1 is 1. The square root of 4 is 2. In between between the square root of 1 and the square root of 4, I'll find the square root of 2 and the square root of 3. Okay? Why? Because the square root of 2 and 3 are not perfect squares. They are not two same numbers. You see here, 1 times 1 gives me 1, and 2 times 2 gives me 4. So there is no two same numbers that I can multiply will give me this. 2 will give me the square root of 2, or will give me the square root of 3. So now, what am I going to say? If I want to find the square root of 2, I'm going to estimate where it is. Since I know it is between 1 and 4, okay, the square root of 2 is between the square root of 1 and the square root of 4. So I will say the square root of 2 is between 1 and 2. Okay? And the square root of 2 is closer to 1 than it is closer to 2. The square root of 3 is closer to 2 than it is closer to 1. Closer does not mean over. Closer means it is less than 2, but it is nearer to 2. Okay? Alright, so let us look at an example over here. Estimate the square root of 2 to the nearest integer. Okay? This means your answer has to be a whole number. Okay? And because your square root is positive, your answer should be positive. Alright. The root of, so here is the question, square root of 2. You want the square root of the perfect square before 2, which is 1. So the square root of 1. And you want the square root of the perfect square after 2, which is, oh, I did this, not 9. This will be 4. Okay, this should be 4. So therefore, this is 2. Okay, so the square root of 2 is between 1 and 2. Okay, so what am I going to write here? The square root of 2 is between the square root of 1 and the square root of 4 on the number line. That's where I found the square root of 2. Between the square root of 1 and the square root of 4. The square root of 2 is between the whole numbers 1 and 2. The square root of 2, is between the whole numbers 1 and 2. Okay? So, the square root of 2 is closer to the square root of 1. So, the best integer estimate for the square root of 2 is 1. Okay. All right, let's do another example. Okay, here I want to estimate the square root of 24. I go back to my number line. I look for square root of 24. Who is the perfect square after square root of 25? Who is the perfect square before square root of 16? So the square root of 24 is between the square root of 16 and the square root of 25, which I wrote over here. It's between the square root of 16 and the square root of 25. Okay? So, what is the square root of 16? 4. What is the square root of 25? 5. So, the square root of 24 is between the integers 4 and 5. So, I wrote here, square root of 24 is between square root of 16 and 25 and the square root of 25 on the number line. I also say the square root of 24 is between the whole numbers 4 and 5 on the number line. So, the best estimate, so I will write the square root of 24 is closer to the square root of 25. So the best integer, so the best integer estimate for square root of 24 is 5. And this is my answer. Okay? This is helping me think. But the answer to my question is this. Because the question said estimate the root of 24 to the nearest integer. Okay? Alright. So, oh, there, I wrote it over here. Why did I think I didn't write? The square root of 24 is closer. The square root of 24 is closer to the square root of 25. So the best integer estimate for the square root of 24 is 5. Okay? Now, how can I do this without the calculator? Because I can do with the calculator. So, let us see with the calculator. I turn on, I press square root, I press 24 equal, get SD. And you see this is 4.8. If I round this to the nearest whole number, I get 5. So that's why I say the square root of 24 is closer to 5. Now, I want to do this without the calculator. Okay? So, find the square root of 15 without using the calculator. So, I write my question in the middle. I pick the perfect square before and the perfect square after. Okay? So, the perfect square before is 9 and the perfect square after is 16. You should know your times table. You should know your perfect squares. Okay? Now, the square root of 9 is 3. The square root of 16 is 4. So, you always write the answer to the first square root as your whole number. So, the square root of 9 is 3. 3 becomes the whole number. 3 is the whole number. Are we together? This becomes your numerator. This becomes your denominator. So 15 out of 16. And you always subtract the first square root from the numerator and the denominator. So you will get 15 minus 9 and 16 minus 9. You get 6 out of 7. You change 6 out of 7 to a decimal. So that becomes 3.85714. And because your decimal will not terminate, you will put the 3, you put ellipses, okay? You put the 3 dots, okay? So, if I do 15 minus 9 over 16 minus 9. Remember, you're always subtracting the same number. You get 6 over 7. See, I got 6 over 7. Then I change it to decimal. I got 0.85714, like that. And I put my dots. Okay? So, the square root of 15 is about 3.857. And I did this without the calculator. Okay? Now, square root of 15 is about 3.9 or 4. We should just say 4 because you're rounding to the nearest whole number. The square root of 15 is about 4, okay? The square root of 15 is closer to 16. Sorry, the square root of 15 is closer to the square root of 16 because 3.9 is closer to 4, okay? The square root of 15 is between the integers 3 and 4. Is between the integers 3 and 4. So the best estimate will be, the best estimate for the square root of 15 is 4. That will be the best estimate. All right, let us do another one for 43. And you see how to do it. So we're estimating without using the calculator, okay? Square root of 43 is between the square root of 36 and the square root of 49. The perfect square before 43 is 36 and after 43 is 49. Okay? Alright, so then I will write the answer to the square root as my whole number. Remember, this is an estimate, so you don't use equal sign, you use approximate sign. And then you write your numerator, you write your denominator. Then you always minus the first square root. Okay, so 43 minus 36, 49 minus 36. You will get 7 out of 13. Convert 7 out of 13 into a decimal. You get 0.538, so it becomes 6 because it's a whole number, and then you write the decimal and you put the ellipses. Okay? And then this will help you think. Okay? The reason why I write these statements here is to help you think. Square root of the square root of 43 is about 6.5, which is also about 7. So the square root of 43 is almost 7. The square root of 43 is in the middle because 6.5 is the middle of a number, 0.5. When you have 0.5, it means it is halfway, okay? So if I was to draw a number line, here this will be the middle, square root of 43, and then this distance will be the same as this distance. So here I will have the square root of 36, and here I will have the square root of who? 49. Okay? 7. And this is 6.5. Okay? Alright. Square root of 43 is closer to 49. Square root of 49 because 6.5 when rounded to the nearest whole number, it is 7. So, and the square root of 49 is 7. So that's why I said square root of 43 is closer to the square root of 49 than it is to 36. Okay? Let's do cube root. So I drew cube root the same way. I drew my number line. I wrote all my cube roots from 1 to 30. And then I selected which ones were perfect cubes. So 1, 8, and 27 are perfect cubes. Cube root of 1 is 1. Cube root of 8 is 2. Cube root of 27 is 3. Okay? So I want to estimate the cube root of 16 to the nearest integer. I do the same thing. I put the question in the middle. I choose the perfect cube before and the perfect cube after. This number will always be less than the question. This number should always be bigger than the question. All right. The cube root of 8 is 2. The cube root of 16 will just remain like that because we don't have 3 same numbers that when we multiply will give us 16. And then the cube root of 27 is 3, okay? So I will say the cube root of 16 is closer to 2 on the number line. 16 is closer to 8 than it is to 27, okay? How do I know? I look over here. 1, 2, 3, 4, 5, 6, 7 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. So here is 11 spaces. From 16 to 27 is 11 spaces. See? From here to here, I should have 11 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then from 16 to 8, 1, 2, 3, 4, 5, 6, 7, 8. 8 spaces. 8 spaces is a shorter distance than 11 spaces. So that is why I said the cube root of 16 is closer to the cube root of 8 than it is to the cube root of 27. So the cube root of 16 is 2. Okay? It is closer to 2 than it is closer to 3. So this, it is closer to 2. So that's what I wrote. The cube root of 16 is closer to 2 on the number line. The cube root of 16 is between the integers 2 and 3. The best integer estimate for the cube root of 16 is 2. Okay? Alright, let us do this using the method without the calculator. How to estimate cube roots without the calculator. So here I've been given the cube root of 72. Estimate this cube root without the calculator. So then I will write my question in the middle, which is the cube root. You must put cube root. If you don't put the root and 3, my friend, you'll be talking about a totally different number. Okay? See? Like here I forgot. I need to put cube root. Alright. 72, the perfect cube before 72 is 64. And the perfect cube after 72 is 125. Okay? So, you write the answer to the first cube root as your whole number. This becomes your numerator. This becomes your denominator. 72 out of 125. You always subtract the first root. So you subtract 64. You get this. You change 8 out of 61. This is 61, not 64. 61. 125 minus 64 is 61. If you change this to a decimal, you should get 0.13114. So then this as a decimal is 4.13114 with ellipses because this decimal does not terminate. And then you write your sentences. The cube root of 73 is closer to 4. Okay. See, how do I know this? Because this is 4.1. If I round it to the nearest whole number, I will only get 4. The cube root of 72 is about 4. The cube root of 72 is between the integers 4 and 5. The best estimate for the cube root of 72 is 4. Let's do 670. Estimate the cube root of 670 to the nearest integer. Find the perfect cube before, which is 512, and the perfect cube after, which is 729. Then the cube root of 512 is 8. And then you write 8 as a whole number. This is your numerator. This is your denominator. You always minus the square root that was before the question. Okay? You get this as a fraction. You change this to a decimal and you should get that. 8 becomes the whole number and you change this, you should get 0.72. 8, 11, okay? And then you put ellipses. Then you write your sentences. The cube root of 670 is between the cube root of 512 and 729. The cube root of 670 is between the integers 8 and 9. The cube root 670 is about 9. So the best estimate for the cube root of 670 is 9. How do I know? If I round this number to the nearest whole number, I should get 9. So the best estimate for the cube root of 670 is 9 because when I round my decimal to the nearest whole number, I will get 9. Okay? All right. So I made a cheat sheet. It is easier if you make your own cheat sheet so you look at without confusing. So let us look at the square roots. If you look at the square roots, the numbers I wrote in red are your perfect squares and their square roots. Okay? So if I want to estimate where is the square root of 2, the square root of 2 is between 1 and 2. The square root of 5, 6, 7, and 8 are between 2 and 3. Okay? There will be more than 2 but less than 3. The answer to these in pencil will be more than 2 but less than 3. The answers to these ones will be more than 3 but less than 4 because they're between there. So you need to look at the question and wonder where it is on your list. The same thing I did for cube roots. If I want to estimate the cube root of 5, I know it is between 1 and 2. It has to be more than 1 and it has to be less than 2. Okay? If I want to find the cube root of 39, I know it is between 27 and 64. So that means, the cube root of 39 is between the cube root of 27 and the cube root of 64, which means my answer is between 3 and 4 on the number line. Okay? So make your own cheat sheet so that when you're doing your work, it is easier. You just go to your paper to locate and see, and it is easier for you to find your answer. Let's do some word problems. Okay? So here you have the area of Marwa's square garden. Keyword, square garden. I draw it. It is always important for you to draw the square. As you read, you draw. Is 5 square meters. So that is inside here. Area is 5 square meters. Like that. Find the perimeter of the garden. They want the perimeter. So for you to find the perimeter, you must know the side. So the question didn't tell you to find the side, but you must find it first. So step 1, you don't know the side. So you need to find it. So step 1, find the sides. Okay? And the sides are labeled S. So you know area equals side times side. You know the area is 5 and this is equal to S squared. 5. Okay? Now to find S, what do? You square root both sides. Okay? The square root of 5, okay, I don't know because it's not a perfect square. So S is equal to the square root of 5, okay? Now, this is not your answer because the question says find perimeter. So then I continue. Perimeter equals S plus S plus S plus S. How do I write S plus S plus S? That is 4S. Now, do I know my S? I know my S is 5. So this is 4 multiply the root of 5. And because it is perimeter, my unit is meters. Okay? Now, what did the question say? The question said I needed to estimate